This unit is about probability, and we're going to start with simple probability. So probability is just the likelihood of something happening. It has to have at least two different outcomes. So there's two different results. That could be a team could win or lose. A coin could be heads or tails. There could be a 40% chance of rain. It's going to rain or not rain. Those are two possible outcomes. There could be more outcomes. You're going to roll a die and you have 6 possible outcomes then. You could have 1, 2, 3, 4, 5, or 6. So as long as there's 2 possible outcomes or more, we can create a probability, and that's how likely is whichever event or outcome to happen. So first off, we're going to look at experimental probability. And so this is just calculated by trying things out. So we run an experiment, we flip a coin 50 times and see how many times head comes up and how many times tails comes up to see what the probability of each is. So when we do that, what we have is a formula, the probability of event A. So whatever event we want to happen, say the probability of flipping tails is equal to the number of times the event occurs divided by the total number of trials. So if we're talking about flipping coin 50 times to find tails, the probability of flipping tails is the number of tails that occurred in those 50 flips divided by the 50. So maybe if tails came up 20 times, so then it would be 20 divided by 50 is our probability. So an example, so there's a new card game out there. It's called Unicorn Pickles. It has 3 types of cards in the deck. There's unicorns, there's pickles, and there's one-eyed sloths. So what we're doing here is going to do an experiment to see how many of each type of card is in the deck or what the probability of drawing those cards is. So we run a trial, we take the deck, stack it up, we pull out cards 30 times, we pull out a card, see what it is, and put it back in. When we do that, we find that there are the unicorn cards drawn 12 times, the pickle cards drawn 8 times, and the sloth cards drawn 10 times. So there's our results, and then we want to calculate some probabilities. So we want to calculate the experimental probability of drawing each card, and we'll do that as a percent, a decimal, and a fraction. So the probability of drawing a unicorn card, okay, we'll use U for unicorn as our event, is the number of times the event occurred. In this case, we had 12, divided by the number of trials, which was 30. So we have 12 divided by 30, and that will simplify down to 2 over 5. And so 2 over 5 is then our probability of drawing it as a fraction. As a decimal, that would be 2 divided by 5, or 0.4. And as a percent, that would be 40%. We multiply that by 100. So there's a probability of a unicorn card. 40% of the time you'll draw a unicorn card. The probability of drawing a pickle card, so probability of P, is 8 cards were drawn. So the number of times the event occurred was 8 divided by the total of 30. So 8 out of 30, which is going to give us 4 out of 15. And 4 to 15 is 0.2667. So there's our probability of drawing it as a decimal, and then as a percent, that would be 26.67%. And then finally, the probability of drawing a sloth card is going to be the 10 events divided by the 30 trials, which is 1/3, which is going to give us 0.3333 or 33.33%. So we have our fractions, our decimals, and our percents. Now, often in probability, we like to work with the decimal portions. It just works out because the probability of everything happening then becomes 1, as I'll note in the later part of the note here. But what is the sum of the probabilities? Well, let's work with that section. And if we add those up, 0.4 plus 0.2667 plus 0.3333. That equals 1. That's it. And if we were to add up the fractions, we would get 1. And if we were to add up the percents, we would get 100%. The sum of all the different possible probabilities is always going to be 1. So everything that's possible, if you take all the events, you should total up to 1. And if you don't, then you're missing an event or you made a mistake in your calculations. Now, we know our experimental probabilities of finding these different cards. So we want to take a look. If we have a deck that's made up of 75 cards, what would you expect the number of unicorn cards to be? So how many unicorn cards would you expect to find in a deck of 75 cards? So our probability of drawing a unicorn card was 0.4. So 0.4 or 40% of 75 should be unicorn cards. And 0.4 times 70% is going to give, or 75 should give us 30. I'm going to double check that. 30. So it gives us 30. So there should be 30 unicorn cards in the deck. Now, do note, this is experimental probability. The deck may not have 30 unicorn cards. It may have 25 unicorn cards, 25 pickle cards, and 25 sloth cards. With experimental probability, you won't necessarily get an accurate answer. If you flip a coin 3 times, you'll get maybe heads, and tails. Does that mean heads is more likely than tails? No, it's actually not. You should have an equal chance of getting heads or tails. The more trials that we do, if we, instead of doing 30 trials, say we did 1,000,000 trials, what we should find is the probability should, not guaranteed, but should approach being their exact numbers. And we'll do some simulations with computer programs later to show this. And we'll do like 10 million trials of something. So again, as I noted before, the sum of all the outcome probabilities. So if we take all our outcomes, we had the 3 outcomes here. We either draw a unicorn card, a pickle card, and a sloth card. The sum of all those, in any case, should be 1. And then lastly, just subjective probability, because it comes up in real life. It's not really mathematical, but subjective probabilities are those that are just guessed at. I give the Blue Jays a 47% chance of winning the World Series. I give you a 27% chance that you'll make a paper ball and throw it into the wastebasket. Something like that, where we don't actually have evidence of it. We're just kind of making assumptions on that. So that is a subjective probability. So experimental probabilities, the number of times the event we want to occur happened divided by the total number of times that we tried it out.